Let's go through practice test 2, the solutions, explanations on how you would solve each one of these problems. Question number 1 is asking you to calculate the oxidation number of chromium in CrO3. To do that, remember that we're going to use some rules, like we know that oxygen is always -2. We have 3 oxygen atoms in this molecule, so altogether they have a combined total -6 charge. There is no overall charge on this molecule, which means that the oxidation number for the chromium needs to be such that it plus -6 from the oxygen will equal 0. The sum of the oxidation numbers always adds up to the overall charge. Balance a redox reaction in an acidic solution. It looks like I'm helping you out because the negative charges are kind of hard to see on there, so I've indicated that those BrO3 and Br each have a -1 charge. So the first thing that we need to do is separate into half reactions. We have BrO3 that is turning into Br minus, and then we also have N2H2 that is turning into N2. And I give myself a lot of room here. I don't know how much stuff I'm going to have to fill out. So we're going to start, first of all, with this half reaction right here. First thing that we do is balance the bromines. They're already balanced. Now we balance the oxygens by adding water. Since we have 3 oxygens on the left side, we need to put 3 water molecules over on the right. Now we balance the hydrogens by adding H+. We have 6 hydrogens on the right side, so that means we need 6 H+ on the left. And the last thing that we'll do is balance the charge. We have on the left-hand side, we have a total of +5, and on the right-hand side, we have a total of -1. We charge balance by adding electrons, so we take the highest charge, that's +5, and we have to add enough electrons to bring it down so that it matches the low charge. So in this case, we need to add 6 electrons. Now we're moving on to half reaction number 2. First thing we need to do is balance the nitrogens, which they are. We don't have any oxygens to balance, so we move straight to the hydrogens. We add 2 H+ to the right side. Now we charge balance. Our left side is neutral. Our right side is +2. We have to take the highest charge, +2, and add electrons to bring it down to the lower charge. Before we combine these 2 reactions, we have to make sure that they each have the same number of electrons, which means that we need to multiply all the coefficients in the second reaction, multiply all the coefficients by 3. So that way each half reaction will have a total of 6 electrons, and now we can combine the 2 together. BrO3 minus plus 6H plus 6 electrons plus 3N2H2 makes Br minus 3H2O, 3N2, 6H plus, and 6 electrons. And the last thing we do here is cancel out anything that appears exactly the same on both sides of the equation. So that's going to be our 6H pluses and our 6 electrons, and there we are. Balance, question number 3, balance the reaction in a basic solution. So when we're balancing in a basic solution, we need to get rid of our H pluses, and we'll do that by adding the same number of OH minuses. However, this particular reaction has no H pluses in it at all. So it's kind of a trick question. It's already balanced in basic solution. Because there are no H pluses in the equation, we don't need to worry about it. Question number 4, for the reaction in problem 2 and 3, is the conversion of BrO3 minus to Br an oxidation or a reduction? So we can figure that out by, we want to be referencing this half reaction right here. In our trick, oxidation is loss of electrons, reduction is gain of electrons. So we're looking at where are the electrons? Are they being added to BrO3? It looks like they are. So since we are adding or gaining the electrons, this is a reduction. Number 5, calculate E cell for the spontaneous reaction that would occur between nickel and lead. The reduction potentials are on the last page. So since this is telling us if it's a spontaneous reaction, that just means that we need to figure out how to do positive E cell. And so on a different screen, I've scrolled to the end of the test to find the reduction potentials. For nickel, it's negative 0.23 volts. And for lead, it is negative 0.13 volts. And our job is just to figure out how to put those two numbers together to get a positive number. The equation for calculating E cell is cathode minus anode. In order for this to end up being a positive number, we need to do negative 0.13 volts minus negative 0.23 volts. That is going to give us a positive 0.1 volts. And question number 6 is asking us to label in this diagram that did not translate very well. But this is supposed to be a beaker. This is supposed to be a galvanic cell. Looks like I made it go up a little too high. So here is one beaker, here is one electrode, here's the wire that's connecting to the second electrode, beaker, salt bridge, and it's saying in the problem, it's saying that this is the anode, which means that this is the cathode. So we have to figure out what is where in terms of the chemicals. Now, fortunately, the problem number 5, the way that we worked on it, that helped us figure out which is which. We figured out that the cathode needs to be the one that has the negative 0.13 volts. So that is the lead situation. So that means that our electrode, our cathode, is the solid lead, and we match the electrode and the solution. So the solution is going to contain lead as well. And then that means by process of elimination that our anode needs to be nickel. And again, we're matching the material of the anode and the component of the solution. So that's going to be a nickel ion solution.